Good morning, Professor. This is the presentation for Group 8 for our technical presentation for the global energy consumption trends and forecasting. Next slide, please. So our project synopsis, the global energy consumption trends and forecasting. This project is going to analyze the historical energy data, and is going to help us build predictive models to estimate the renewable energy share of countries worldwide. So by identifying these trends and transition leaders, this project is supporting data-driven policy decisions and the global shift towards sustainable energy. We are presenting interactive dashboards, which will help us to visualize the insights that we've deduced for stakeholders and enhance strategic planning. So now we're moving to the technical part of the project. So in our technical part, in our Jupyter environment, we imported the necessary libraries for this. We imported also the visualization libraries, the pandas and all of that. So we went further to upload our CSV, which is the OWID data, energy data CSV into the environment. We dropped columns that had 90% of their missing values. We dropped rows that had missing years and missing countries. We also filter only the countries that had rows with valid ISO codes in this. So we further went to clean the data set, and we printed our clean data set in it. We selected only the relevant columns, as you can see here, the country, the population, all of that. We selected them, and then we went further to handle the missing values. We also went further to fix the data types by setting numeric columns. We converted the yearly columns into integers, and also we went further to drop the duplicates, and then finally we saved the clean data set that we had. Then we went on to check for the result by using the df info, df ed. We also described the data set. We made sure to run the description, so which shows that for the Afghanistan, we had about, can you scroll? Yeah, 5 rows and 24 columns for that. And also we went further to check the data types again by running the df info. Can you scroll down more? Yes, so we describe, like I said. Can you go down? I don't want to say something. So that was what we did. So we just printed the columns, and that was what we did. Thank you. Tosin, please take it over from here.
All right, thank you. So after cleaning the data, we tried to visualize the global primary energy consumption from 1900 to 2022. And here we can see that there's a steady growth increase in energy usage, especially after 1964. Can we go to the next one? So this chart shows that it compares the global fossil fuel and renewable energy consumption from the time period that was mentioned earlier. And the renewable energy consumption remained low in decades, but it started rising after 2000. And this could just be as a result of the growth of fossil fuels still being dominant in the global energy mix. And the wide gap highlights the slow transition from sustainable energy resources. This line chart shows how the percentage of global energy from renewable has evolved since 1900. And we can see that there's a rise beginning from 1970, followed by the period of a short stagnation. And this is a recent surge indicates that there's an accelerated growth or adoption of clean energy sources. Next one, please. So this is the top 10 global energy consumers. Here we can see that China and the US are the world's largest energy consumers, and followed by India and Russia. Next one, please. So here we can see that the total energy use is high for fossil fuel, which dominates energy mix. And this pattern reveals that a global dependency is on the renewable sources, even among these highly advanced nations. So here, for the next one, energy consumption by continent. So here we can see that Asia has shown the most significant growth in both fossil fuel and renewable energy consumption, especially after the 2000, and North America and Europe were early leaders in fossil fuel use, but have since declined slightly. So here um, the we have the renewable energy consumption over time by continent. Can we go to the next one, please? Yes, so here Asia has taken over both Europe and Northern America in fossil fuel consumption since the 2000s and continues to surge upward. Can we view the country level trend? Okay, so for the country level trend, we have China and India, and they both show a sharp rise in fossil and renewable use. And the next one will be Germany and France. Yeah, fossil fuel consumption has declined steadily while renewable energy usage, especially in Germany, has increased significantly from 2010. And the next one would be US and Canada. The US and Canada, US remains a high fossil fuel consumer, but both countries show a steady growth in renewable, with Canada dominating consistent progress. And next, we'll be going to the energy source. Can we see the energy source distribution for continents? This is for country. Okay, so here we have the energy source for the continents, and here we can see that for coal consumption, Asia has been the highest consumer. So now we can go to the model selection. Thank you.
So for our model selection, we decided to work on predicting renewable energy share. The goal of the selection was to predict how much of energy comes from renewable sources and identify the top performers and underperformers from our data sets. We decided to build a regression model to predict this energy share based on several economic factors and indicators. We started by pre-processing new columns for our data sets like GDP per capita, fossil per capita, energy per capita, and we split our data set into train and test splits. We decided to build a model with random forest regressor, but we used other ones like XGBoost and linear regression. For random forest, we created new columns based on we talked about using several economic indicators such as GDP per capita, fossil, wind, hydro consumption. So we created a pipeline based on the random forest regressor, and we trained the model, and we passed in random values for those indicators, and we passed it into our model to predict. And as you can see, the predicted renewable share of this random values was 30%. So we created a chart to display our test results against our data sets to check for the top, over, and underperforming countries. And as we can see here, Portugal was the top performing country, and at the opposite end was South Africa. So we also created a bubble chart for better visualizations of the results we had with random forest regressor. So we did the same process with XGBoost. We used an XGBoost algorithm model, created a pipeline based on the test splits we used earlier, and we also created a chart that showed the same results we got from the random forest, and you can see Portugal also and South Africa also. And the last one we decided to use was the linear regression model. So the same process applies also for this. And we had a slightly we had an entirely different results using linear regression. As you can see, Norway was the top performing countries, which is totally different from the first two models we used. And China was the least underperforming countries. We also created a bubble charts for this model too. So I will pass it on to Timmy to discuss about the results that we got from using the three models.
Okay, thank you. So to evaluate our models fairly, we used the 2K regression metrics. So the first one was the root mean square error, which measures the average difference between the actual and the predicted values. And the lower values, the better. And also the R square score, which indicates how much of the target value variable variance is explained by the model, and the closer to 1 for this, the better. So if you look at the charts, so the linear regression has the highest RMNSC, which and a lower R score. So which means it's missed a large portion of the actual energy share variance, and that could be likely to the inability to capture the non-linear relationship. Also, for the random forest, it performed better than the linear regression. But if you look at the XGBoost, which outperformed the two other models, it has a lower score of RMNSC and the highest score of R square. And this shows it made more accurate predictions and explained the most variance. So based on the metrics that we used, so XGBoost emerged as the top performer. And if you go to the K-fold cross-validation, so to ensure the results were a little bit robust and not just a single train test split. So we applied like the fold cross validation, and from our model, random forest had slightly lower RMNSC, in the cross validation if you check, which is 6.9, and XGBoost was even more stable for this across the folds. It has an average value of RMNSC of 1.65, and the R square is 0.96. So, which means that it is better, the generalization and it's observed in the final test sets is okay. So, and for the final model selection, so the XGBoost, we have just said we choose that because it's the best performer. It performed better. So, and the reason why we chose that, just a summary, it has a better value of RMNSC and R score, and it gives us a strong generalization capacities, and it's built-in regularization features, which helps us to avoid overfitting. So, and in overall, this makes it the most reliable model for our goal. The goal for this project is to predict the renewable energy share for each of the countries, and we also generalized for the continents. So, but this shows that XGBoost is the best rather, and and on the energy, and based on the indicators that we used, is the best. So, thank you for listening to us, Prof.